तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Today's lecture on numerical methods in programming, we will continue our discussion on the pointers, the use of pointers. To start with, we will summarize what we did in the last class. So we looked at the representation of pointers in a program. So how do we actually put in a pointer? That is using the declaration of the pointer. That is, here is an example. We used defined a pointer called NUM, okay, using this declaration. It is type integer, okay, and we use this asterisk operator to define this pointer. Okay, the pointer is defined as integer star NUM. So we, in the last lecture, we actually saw the use of two operators. One is the asterisk and the other one is the ampersand operator. Okay, so we will see that again here. Okay, so we created a pointer here called NUM, okay, and now we are directing this NUM to the address of a number n. So that's what the use of the ampersand operator is, basically to give the address of the thing. Okay, so that this operator returns the address of this argument n and then assigns that to NUM. So and then and this sets the pointer NUM to the address of the variable n. That's what basically the idea is. Okay, the idea is to get the address of the operator n, okay, and the variable n, and then give that to the variable the pointer NUM. Okay. So now we will see the use of the operator asterisk operator. So that is now we are going to assign this whatever the NUM pointing to that variable to another variable m. So that's what we see here, right? So m equal to star m. Okay, so this ampersand, sorry, the asterisk returns the data to which it is pointing to. Okay, so that's one thing which we saw, and the next thing which we saw in the previous thing was arrays. Okay, so here is a declaration of an array. So arrays and pointers are the one which we use interchangeably in the last lecture. Okay, so here is a declaration of an array, again in type integer. Okay, so it's a array of dimension 4. Okay, so we dimension it using this. So we use this. So the elements of the array, we can fix the elements of the array would be now 0 to 3. Okay, because we dimension it as 4. Okay, and then basic thing to note is that we use this square brackets instead of the brackets which are used to when we write arrays in the nodes. Okay, so this is because this brackets are used to represent functions. So to distinguish it from the functions, we use the square brackets. Okay, that's something to be keep in mind. Okay, so now we'll see the use of how do we go from one array, how we use arrays and pointers interchangeably. So that is here. Okay, so now this thing sets you that. Okay, so tells you that thing. Okay, so now we have integer pointer declared NUM. Okay, which is type integer. Okay, and then we are assigning, so now we say that NUM equal to x. Okay, so now x was an array which we saw, right? Okay, so now when you say NUM equal to x, okay, now that will point to the base address of array x. Okay, that's to the base element of x. That's what it's pointing to. It will point to. Okay, so now if you say NUM equal to x of 3, then NUM would point to the last element. Okay, that is the third element of the array. Okay. And so we can increment. So if you set NUM equal to x and then if you say NUM plus plus, then it will point to the next element of the array. Okay, that's what we would see. Okay, so So this would point to x of 0 and this would point to x of 3, etc. Okay. So now if you do num plus plus, it will send the pointer to the next element of the array, and we can continue doing all you can read off all the arrays in the elements in the array by doing this. Okay. Okay, so remember in this that x we said is an array, okay, but x is also a pointer to the base address of that array. So x is an array and it's also a pointer to the base address of that array. So that's what we remember from last class. Okay, so now how do we print out the address of each array elements? Okay, so we can do that. So now here is another array declaration. So this is also an example of declaring arrays. Okay, so here is I have not only defined the array, okay, and we also declare the array, we also assign numbers to it. Okay, I can do this way also. Okay, so now here is num is an array, okay, and I have given it 10, 20, 30, 40 and 50 as the elements of the array. So num of 0 is 10, num of 1 is 20, num of 2 is 30, num of 4 is 40, and num of 5 is 50. Okay, so I can define. Okay. So this way, so this is another way of doing it. Okay, and then now I have defined another pointer. So that's another integer type pointer. We call it j. Okay. So now this is the definition of pointer, and that's the definition of an array. Okay, slightly different from the way we defined earlier, but this is another possible way of doing it. Okay. And now I assign the j, I will make the j equal to num. This statement basically means that j would point to the base address of the array num. Okay, as I said, num is an array, but it's also a pointer to the base address, right? So the j is a pointer. Now that's pointing into the base address of num. Okay, and now I can read off this as j of 0 as the address of num 0, and j of 2 as the address of num 2, or j of 1 as the address of num 1, etc. Okay, that's the only way I can get the address of an array element. Okay, so you need to have a pointer which is pointing to the base address, okay, and then you increment it. Okay, so that way you can get the all the array elements, or you can read off the address of each of the array elements. Okay, so we see this in a program. Okay, so here is a program which would implement this idea and prints out the addresses. Okay, so we have made the usual include statements, and then I have declared this array num here. So it's a 5, it has dimension 5. Okay, so it has num going from 0 to 4. Okay, so and then I have this pointer. Okay, and also I have an integer I, and so this is an integer I, and there is an integer pointer which is j. Okay, okay, so now I did j equal to num, and then I'm going to print out now. See, by this statement I can print out all the addresses of the array element. So here is %u is used to print out the array elements. Okay, so %d is a syntax for printing out an integer. Okay, so and again this is integer. So what we'll do, what we'll print out here is we'll print out the address of j of I. So I goes from 0 to 4, right? Okay, so it will print out the address of j of I, or the address to which j is pointing, j of I. And it will print out what value it is pointing to, and it will also print out num of I. Okay, so that's what we can see. Okay, so we will implement this program, we will put it in and then run it. Okay, so we will see that. Okay, so here. So here is the program. Okay, so here is what the program doing. So here again, so I have declared the array. Okay, I have declared the pointer and the integer. Okay, and I made the pointer to the base address of num. Okay, and then I am running through, I am incrementing I by steps of 1 from 0 to 4, and then I am printing out here the address what this j is. Okay, now if I, and then j of I. So there is a subtle difference here. I am printing out j and the address to which j is pointing to, and the address to which j of I is pointing to. Okay, and then the asterisk j, which is the value of j pointer, and num of I. So let's see what happens if you run this. So we compile that and we run it. So we'll see what we are getting. Okay, so we are getting here the address, the base address, the j, where it's pointing to. So now that remains a constant. Okay, so even when I increment j plus plus, okay, okay, even if I increment j by j plus plus, okay, the base address doesn't change. Okay, so remember the address is the base address remains the same, but j of I is now pointing to different numbers. Okay, the address of the different array elements. Okay, so j of I is pointing to different elements of the array. Okay, so and then I am printing out asterisk j, okay, and I am printing out num of I, and they are the same, right? That's what we expected too. Okay, so the two ways of getting the array elements, I can point a pointer, integer pointer to an array, okay, and I can increment that integer pointer, okay, and then pick up the value of that, or I could use the array element straight away as num of I, which we are used here. Okay. But if you want to get the address, there is only one way of doing it. Okay, we have to say it as j of I. Okay, not if you print ampersand j, okay, that then what you not get the address of the each elements. Okay, you would get only the address of the base address. Okay, that's all we would get. Yes, that's a point to be kept in mind. Okay, so then we also saw, okay, which I go through again, that we can make a pointer to point to another pointer. Okay, that is the pointer to pointers. Okay, this will be useful, especially when you want to read off character arrays and things like that, and also two-dimensional arrays. We will see that in later. Okay, so here is an example. Okay, we have made a pointer here. So then there's a pointer to a pointer. So it is with double asterisk declaration. So star star markup. Okay, so now then I have a character array here. Okay, the array is called course 0 as numerical. That's one array. Okay, and then the first element of the character array, okay, is course 0, and that's given as numerical. Okay, and then I have the second element, which is course 1, okay, and that points to methods. Okay, so now you see here you have an array of pointers. Okay, so that's what you're going to do, and we have a thing called marker, which is going to point onto this. Okay, now let's see what happens. Okay, so we say we make the marker, okay, point to course 0, okay, this element. So it will point to the base address of that, right? Okay, so that's what it will do. Okay, and now so that means the pointer to course 0, this points to numerical, right? That's a value given to that. The string is numerical, and that's what it is going to get. Okay. And then we increment the marker. Okay, so what will happen? It will go to course 1. Okay, so that's what will happen. So it will point to course 1. Okay, so now it will be, that means it will be pointing to methods. Okay, so then you could ask the question, how do I read out each of these characters in the string? And this is the way you can do it. Okay, you can say star marker plus plus. Okay, we saw that in the thing. Okay, so we have this in the bracket here. Okay, that's important. Okay, so we declare it as a double. It's a pointer to a pointer with a double asterisk. You use one asterisk, put it in a bracket, okay, and then say plus plus. So when you say marker equal to course 0, it will point to numerical, okay, and when you say marker plus plus, it will point to methods. Okay. Now having said that, now if you say star marker plus plus, it will point to the next element of that array. Okay. Now we will use exactly the same, okay, when we want to work with two-dimensional arrays. Okay, so this is important. Okay, so you remember this. Okay. Okay, so now we know how to declare pointers, how to declare arrays, and how to use pointers to read out addresses of the arrays, and all these things we know. Okay, so now we see how we can pass arrays to a function. Okay, so we have to see something of the use of functions. Okay, we'll see how to pass arrays to a function. Okay, so that is what we will see now. Okay, so now this is important thing to remember, that in C all variables are passed by value. Okay, except arrays. Okay, arrays are passed by reference. Okay, now what do you mean by this is that, you know, when you pass to a variable to a function, okay, so variable makes the function makes a copy of that variable, okay, and works with a copy, and that's because we pass only the value of that variable. Okay, so normally when you pass a variable to a function, okay, the function gets a copy of that variable and it works with that variable. Okay, so it doesn't, if you change that variable inside that function, okay, it doesn't change the variable in the master program, and the master function, okay, in the main program. Okay, in the main program you declare a variable and you pass that to an array, to a function, and the function change that variable. Okay, it will not change the value of that variable in the main program. Okay, so that's what we mean by, we'll see this with an example. Okay, by passed by value. Okay, as opposed to passed by reference, here we pass the address of the variable. Okay, so you see that we pass the address of the variable, okay, which is some address to some memory location, and now you in the function, if you change that value of the variable, okay, right, okay, it will change that, it will change the value in the main program too. Okay, because we are just working with addresses. Okay, we are not making a copy there. Okay, we are just passing the address. Okay, and we are working with that thing. Okay, we are not making a copy here. So if you pass by reference, it will not make a copy, but if you pass by variable, it will make a copy. Okay, so we'll see that. Okay, so that's the thing. So when you are passing an array to a function, you are passing a pointer to the first element of the array. That's what I said. The name of the array is also a pointer to the first, pointer to the base address, right? So when you pass that, it actually points to the first element of the array. Okay, so when you work with that, okay, it will change. If you pass an array to a function, and if you change any value inside that function, okay, of the variable, if you change any of that, it will change the value of the array in the program from which it is passed. Okay, so that's what you're going to see here. So here is an example. So we have an array declared, right? It's again 10, 20, 30, 40, 50 NUM, and we have these integers here, which are defined as pointers. Okay. So now, okay, so we have okay. So there should be two calls here. Okay, I'll show you the program here. Maybe that's better. Okay, so here we have a program. So we have this declared as an array here. And we have integer I, m, and a pointer, integer pointer, right? And then we have an array dimension as m equal to 5. That's the dimension of the array. Okay, and then we point this pointer to the value of m. Okay, that's what we have done here. Okay, so value of m, and then we are using two print statements. Okay, so we are saying this is actually a function. Okay, print is a function, and so is print1. Okay, print1 is another function. Okay, so now you see in print1, I'm going to pass the value of this function 5, the number 5. Okay, and then I am passing the num. Okay, here. Okay, that is my array. Okay, and I pass j. Okay, now let's look at the print here. Okay. Okay, so that's a print function, function, and the function takes n, b, and so I declared this separately, right. So now you can see that here. Okay, so if you look at this function here, okay, this is my function, right, and this is a call to the function. Okay, so I pass 5, that goes as n here, okay, and I pass num, that goes as b. Okay, so num is an array here, b is an array here declared. Okay, we have seen this before, right. Whatever is in here in the function, you have to declare them here. So I declared n as an integer, b as an array, and l as a pointer. Okay, and I put here 5, num, and j. Okay, that's passed on to that function. Right. Okay, so now then what do I do here? In this function, okay, so I had here in this function I had going from 10, 20, 30, 40, and 50. So that is num of 0, num of 1, num of 2, num of 3, and num of 4. Right. Okay, so the fourth element was 40 there, and I make that here the fourth element of this, okay, into 60. Okay, that's what I do. Okay. And then I also change this value. I assign this value as 15. Okay, I just assign that value as 15, right. And then now I print out these things here. Okay, and I also print out that here after the call. Okay, so two things I am doing. I'll call. So I know you know what the values of this array elements are. Okay, I call this function here. Okay, and then after calling the function, I print out the values of those array elements here. Okay, right, and also this value m. Okay, and inside the function itself, I print out the value of those functions, value of those variables. Okay, both the address and the value. Okay, I print out that here. Okay, and in the process, I also change the last element here. Okay, now we see what happens. Okay, so we'll run this and then we'll see what happens. We'll comment out the rest of the program just to study only that part of it. Okay, so here, so we get the address. Okay, so remember, so we are printing out. What are we printing out? We are printing out the address of the array elements, right? And we are printing out the array element itself. Okay, and we are printing out this value of L. Okay, so that's what we are doing here. Okay, and that's what we get. Okay, so that's what we got here. Okay, and so we got the array element, the address, okay, and we got the number it is pointing to. So you remember the last one, instead of 50, now it becomes 60, right? Because we printed out that, okay, as 60, okay, and now we will go back here, and what are we printing out here? So we are printing out, after we call this, okay, we are printing out the fourth element of num, okay, right? The fourth element of num we are printing out here, okay. And that is precisely what we changed inside this program. Okay, see, look, num is mapped onto b. Okay, so when we call print like this, okay, we are actually passing the base address of num to b. Okay, and then we took up the b of 4 and we made it to 60. Okay, so now that is what now we are trying to see what is how as num. Okay, even though we call num as b here, I changed b. Now the question is, as num changed. Okay, and as m changed, that is what we are trying to figure out, okay, because m is j, okay, right. We again pass the address here, okay, of this integer. We pass the address, okay, here. So then what we see here is that both has changed. Okay, it becomes 60 and 50. That's what we see. Okay, remember it was 5 and 50. Okay, it was right. So what was 50 here now becomes 60 because I changed it in the function, okay, and what was 5 here becomes 15 because I changed it in the function, because I passed the arrays, I passed the address of to the variables. Okay. So now let's see the second part. Okay, now we will comment out this part and then we look at another part of this program, that is okay. Now pass by value. Okay, now thus we saw the example of pass by reference. Now we look at the example of pass by value. Okay, So here again, now I call a different function called print1, okay, which is given here, which is also okay, which is given here. Okay, so it's the function called print1. Okay, now the print1 is going to get everything by value. Okay, so we are making a similar call here in the print1. Okay, so now I'm going to pass only the third element of the array. Okay, so I'm going to pass the third element of the array and m. Okay, remember m is an integer, right? M is an integer. Okay, num of 3 is the third element of the array. Okay, so instead of saying num, now I am passing a particular element of that array. Okay, it's num of 3. Okay, and now in this function, okay, I have defined all of them as integers. Okay, now I am also using this example to show you two different ways of passing things into the function. You could have things written as only the names of the variables written here and declarations below that. Okay, or you could have the declaration itself in the bracket. Okay, that's also, I am using this to even demonstrate that. Okay. So here I have said integer k, okay, and integer n. Okay, there are two integers, and then I am passing them, and I change my k value, okay, and n value here. Okay, remember this is the third element, the fourth element of the array, and this is n. Okay, and so now if I put, so remember the first argument was the third element of the array, and the last argument was the value of m. Okay, and I print out here that values, okay, and I print out them inside this function, and let's see what we get. So what we should see is that if you do that, okay, this values we changed it to 80 and 20, okay, but inside the function it was 40 and 5, okay, and it remains as 40 and 5. Okay, so you change the value of the function, value of the variables inside the function, okay, but that inside the function we change the value, but that doesn't change it in the main program. Okay, the main program, whatever the value was, that remains as that. I said m equal to 5 here, and num of 3 was 40, okay, and that's what it's going to be. Okay, when I print num of 3 and m, I will get 40 and 5. Okay, even though I change them inside this program. Okay, because here we are passed by value, not by reference. I hope that thing is clear. Okay. So we see the next thing is to go into two-dimensional arrays. Okay, so that's, as I said. Okay, so now we're not done with one-dimensional arrays and pointers and how to read off addresses and things like that. Okay, now we go into two-dimensional arrays. Okay, and we'll see how we'll read off addresses here and the values here. Okay, so now here is an array, okay, which has 5 rows and 2 columns. Yeah. Okay, so it's called, it's declared as ARR. This array is ARR. Okay, it's 5 2. Okay, this is not the only way to declare the array, but this is one way of declaring the array. I can also declare it as just 2. Okay, with an empty bracket in the first. Okay, so now the reason for this is, it's kind of, it's stored as okay, so now the reason for this is that this array is treated as 5 one-dimensional arrays, one after the other. Okay, so it's important that we declare correctly this second dimension. Okay, it's not important that this is declared, but this has to be declared. Okay, because it's stored one after the other. Okay, so if you don't declare this, then it gets messed up. Okay, all the elements will get messed up. Okay, so you can either declare it as ARR phi 2, okay, or ARR 2. Okay, empty bracket. So now here is the elements, okay, this I have declared this in this way, I put in all the elements here, okay. So it's 11, 12, 21, 22, 31, 32, 41, 42, 51, 52 are the elements of this array, okay. So I have not filled up all the 5 rows, I have filled up 1, 2, 3, yeah, 1, 2, 3, 4, 5, I have filled up all the 5, okay. So now if I say, as in the case of one dimensional array, okay, if I say ARR, okay, now what will it do? It will point to the base address of this array again, okay. So that's the same as in one dimensional array, okay. But the difference would be in actually reading out the elements of the array, okay. Okay, so now we'll see how to read out this array, okay. So first thing to remember that it is, as one dimensional array is a pointer, and now you have to remember that it is an array of pointers here, okay. So ARR 0 is pointer to the first row of the 2-dimensional array, okay. So that's equivalent to saying that, you know, asterisk ARR in brackets, ARR of 0, that's a base address, okay. And then so the first row of ARR, okay. And then if you say, so in general, if you say ARR of I, it's equivalent to saying ARR of ARR plus I, that is, it's pointing to the ith array, okay, ith row, okay, of the array ARR, okay. So we had one dimensional arrays, the name of the array as the pointer to the base address, okay. Now here we have an array of pointers, okay. So now we'll see the use of that in a program, okay. So we can go, if you want to pick up the jth element, okay, we say ARR of I, the ijth element, okay, ARR of I, so that points to the ith row, right, and then say plus j, then goes to the jth element, okay. So that's the way we're going to point out, okay. So we'll see the use of that. Okay, so here is a code which would implement this thing again, okay. So okay, so here is a code which would it's the same thing as that, okay. So I just typed it in here, okay. So it's 2-dimensional arrays and declaration and reference, that is what we are trying to demonstrate in this code, okay. So here, so we have declared the array, okay, and we have 2 integers I and j, and now we want to just change this array elements. This is a way of referring to the array element, right. So we say the 5th row, the first column, right. So that is the 5th row, the first column, okay. So and so I can change the array elements like this. I have just added to that, okay. So sorry, it's the 6th row. So I added one more row into this 6th row and the first column, and the 6th row and the second column, right. So that's the correct thing to do. So it is 61 and 62, okay. So I'm just demonstrating the 2 ways of assigning elements to the array, okay. So I declared it as ARR with an empty bracket and then 2 columns, okay, and I filled up the 5 columns, 5 rows and 2 columns, okay, and I'm just filling up the 6th row by doing this. Okay. I could do this here or here. So that's just to explain, demonstrate to you that you can do this in 2 different ways. Okay. And now I'm going to basically print out the address of ARR of I, okay, and ARR of I plus j, that is the ijth element, okay. So I go through the whole array, okay. I go from 0 to 5, okay, and 0 to 1. So I go through all the rows, right, and all the columns. So that's what we're going to do. So we'll run this and then we'll see clearly what that does. Okay, so now that's what it's printing out. So what is it printing out? So we come back here and then we look at this thing. Okay, so I just checked that. Okay, so this this 1, 2, 3, 4 is what was printed here. 1, 2, 3, and 4. So we can see that. Okay, so you can see the last one, that is basically just printing out all the elements in the array. So we see 11, 12, and then so first go to first row, right, and then print out the 2 columns. Okay, so remember this is going through the rows, right, and 2 columns. So we can take the first row and go to the 2 columns. Okay, that prints out 11 and 12. Okay, and then it goes changes the row to the next one and prints out 21, 22, etc. Okay, that's what it's doing. Okay, and I am printing out the address here. Okay. So what is printing out the first address is array ARRI address. Okay. So now you can see that that's the address of the row. Okay, that is the address to the row. Okay. So it's the first row. This is the address, right? So then when you go to the next row, the address changes again. Okay. So within that row, okay, when I change the next column, okay, that address doesn't change. The column addresses change. Okay. So you can see that it is how it is stored, right? So you can see that this is the first row, first column element. Okay. This is the first row, second column element. Okay. Then the row changes. Okay. So there is a second row, first column, and the second row, second column. Okay. And then it goes to the third row, first column, and so on, right? And you can see that it is stored in a continuous, in a serial fashion. Okay. All the elements. Okay. So you can see column by column it is continuous. Okay. Sorry, row by row. So in a row, 2 columns. That's why I said if you don't declare how many columns are there clearly, okay, then it get confused. It will confuse between whether this is the first element of the second row or the third element of the first row. It would not know, right, unless you actually tell what is the number of columns are. Okay. So that's why it's important to declare the second part. Okay. So now I have declared. I just wanted to show you here in this program, okay, that another way of actually printing out that number. Here I said, asterisk ARR plus I plus J, ARR plus I in the bracket and then plus J, and then the whole thing in a bracket and another asterisk. Okay. You can get exactly the same number by doing asterisk ARR plus I alone. Okay. So ARR of I, so that's the array. Okay. So you can pick up that array, okay, and then plus J, okay, and then do the asterisk of that, because ARR of I is also a pointer to that array. You remember that, right? Okay. So that's what we see, and we get exactly the same numbers if you do this too. Okay. There's 2 different ways of doing it. Okay, so that is the use of how do we read out the elements of the array, of a 2-dimensional array. Okay, so now we go to the pointer to this array. Okay, now we saw 2-dimensional array, and we said 2-dimensional array is an array of pointers, right? And I can read out each element of this array, and I can get the address of each element of this array by using that arguments. Okay, so now we say that like we had for the 1-dimensional array, okay, we had a pointer pointing to the 1-dimensional array, and we incremented the pointer, okay, and moving along the array and reading out the addresses. We can do similar things here. Okay, so now here is the declaration. So here is an array, okay, a 2-dimensional array. Okay, so here we see that we have different ways of printing out the address of 2-dimensional arrays. Okay, so I showed you that here, that you can have, for example, 2 different ways of printing out this array elements. I just demonstrate that here again. Okay, so I can use either a asterisk bracket ARR plus I plus J, or I can use asterisk of and a bracket and ARR I plus J. This is 2 different ways of printing out the elements of the ijth element of a 2-dimensional array. Okay. We can see similar things in the case of 1-dimensional array too. Okay, so for example here this statement is a 1-dimensional array. Okay, so the array is just NUM as we seen before. Okay, and there are 2 different ways of printing out that again. Okay, I could use a pointer and point on to the element, and then I could print out that element, or I could print out B plus I. So because B here, remember this function here. Okay, so I'll go through this once again. Okay, so here I am calling this function print. Okay, this print function. okay, and this print function has got this array as b, okay, num as b, okay, and I am again using that here. So b is the base address to the array b, okay, and I could say b of b plus I and an asterisk to that, an asterisk of asterisk bracket b plus I will again print out the same thing as asterisk j. Okay, so that's similar to saying here that I could use ARR of I now plus I, right, and then print out the address, okay, print out the value. Okay, there are two different ways of printing out these numbers. Okay, so now we go into the next part, that's the pointer to an array. Okay, and here is an array which is a two-dimensional array. So it has 1, 2, 3, 4, 5 columns and 3 rows. Okay, sorry, 5 rows and 3 columns. Okay, and now what do we read out how do we put a pointer to this array? So here is, so we saw in the case that we have a pointer to this array by just saying j. Okay, so that's a pointer to an array. We could have a integer pointer which is pointing to this array. It's possible to do that, right? So we can have integer pointer which is just pointing to this array. Okay, and similarly we have an integer pointer which is pointing to this array, but there's a two-dimensional array, so we need an array of pointers to point to that. Okay, so that's what it is. Okay, so q is an array of pointer. Okay, and then that is pointing to this. Okay, so so stating q, now if we just take q equal to ARR, and q would just point to the base address of array ARR. Okay, right. So then so that means it is pointing to the first row, first element, right? That's what we saw before. Okay, okay, so now here is how do we read out that? Okay, so now we take once q, we have declared q as a pointer array. Okay, now we can declare another pointer, okay, which would point to that array q, okay, and read off all the addresses from that, okay, or all the values from that. Okay, so now see here, for example, we have declared another pointer r. Okay, now that's going to point to q, okay, by saying r is integer. See, you have to type it here. You have to say you have to typecast it. Okay, so now q is an integer pointer. Okay, so you say r is another integer pointer, and that is to say r is, you have to typecast it integer, okay, and then q. That's the way you point a pointer to another pointer. Okay, so you have to be careful with this. Okay, so r is integer star q. Okay, so we'll see that in a program. How do we use this? Okay, and then if you say asterisk r plus 1, asterisk r plus 2, etc., that will give you the different elements of that row. Okay, and then you increment q, and then you again run through r. Okay, so that's what you would see. So now if you increment q by 1 with the statement q plus plus, okay, now it will go to the next row. Okay, so you see, then if you go q plus plus, it will go to the next row of the element of the array. Okay, so if you just declare one pointer p, okay, not a pointer array, okay, and then if you again you're going to point a pointer to a two-dimensional array, so you have to again typecast it. Okay, it's a integer star array, and then if you say p plus plus, it will simply point to the next element of the array. Okay, so that's the difference. If you say q is an array, so q is an array of pointers, and that will point to the next row if you increment it by 1. Okay, while if you just say p as integer star array, and then if you say p plus plus, it will go to the next element of the array. Okay. Okay, so now there's no better way to understand this than actually looking through a program. So here is a program which will do this for us. Okay, sorry. So we will see that here too. Okay, so here is a program. So we have an array. Okay, so again an array which has 3 columns, and we have 1, 2, 3, 4, 5 rows. Okay, so we have 5 rows and 3 columns, similar to what we have written there. So this is exactly the same as what we just saw. Okay, and then I have 2 integers, right? Integer I and integer j, and I have 3 different pointers here. Okay, so 2 of them are just integer pointers, okay, and another is a pointer array. Okay, so we have 2 integer pointers and a pointer array. Okay, Okay. So now we are making p equal to integer star ARR. So what will happen? This will p would point to the base address of ARR, right? Okay. And now I am making q point to the ARR. So it will also point to the base address of ARR. And then I am making r point to the first element of the q. Okay. So that's three different assignment statements. Okay. So now we will print out. Okay. So now we will see what we are trying to do. We will print out, okay, the value of p, the address of p, okay, the address of q, okay, and the values to which p is pointing, okay, the value to which r is pointing, and the value to which r plus 1 and r plus 2 are pointing. Okay. So we will see that, and then we would increment p and q by 1. Okay. We will increment both, and then we will again, so once you have incremented q, we again point r to the new incremented value of q, right, and then we will again print out the same thing. Okay. And let us see what we get. Okay. So that is what we are going to see. Okay. So remember what we are trying to print out. So we have p, q and r assigned this way, right, and now we are printing out the first thing we are printing out is the address of p. Okay. So that is the same as the address of q, because both p and q are pointing to the base address of ARR. Okay. So that is the same address. So you get the same address here, right, that is expected. Okay. You get the same address because both p and q are pointing to the same base address of ARR. Okay. And then what is the next one? The next one is the value to which p is pointing to and the value to which r is pointing to. But they also has to be the same because it is the first element of the array. Right? The first element of the array is what these two are pointing to. And now that is the first row, first column. Right? And then we run through the column. Okay. We run through the row. Okay. The second column and the third column. Okay. That is what we have. We have 11, 12 and 13. Okay. So we had 11, 12 and 13, 21, 22, 23, that is the way we have ordered it. So we know we can remember this as the row in element, and this is the column, and this is the row. Okay. So the first row, first column, second row, first column, etc. Okay. So now the next thing is we are looking at the value of, we are incrementing p and then we are incrementing q. Okay. And then we are again printing out the incremented values. Okay. So let us see. So when the p is incremented, okay, the first one is we are printing out the p. When p incremented, okay, it went by 4 bits. Okay, it went to the next element of the array. Okay. So now you see when you increment p and q, okay, they are not pointing to the same address. Right? This jumped by 3. You can see that. This is jumped by 1. Okay. So when you have first assigned p and q to the base address of ARR, they are the same address, of course. We incremented p by 1 and q by 1, and we are printing out the addresses, and you can see they are not pointing to the same address again. Okay, because p just simply went to the next element of the array, right, while q went to the next row of the array. Okay, so we have two different values. Okay, so now again we are printing out the r plus 1, r plus 2, so it reads out the next elements. Okay. While p is simply reading the next element of the array, right? Okay. While r, which is pointing now to the q, is reading the elements of the next row. Okay. So that's a difference. Okay. So that's the difference between the pointer and a pointer array. Okay, these two things you see. So the next thing we should see is that now we know how to define two-dimensional arrays, we know how to define pointers and how to make read out the elements of a two-dimensional array, etc. So now we see how do we pass this array to a function. Okay, in many cases we need to pass an array to a function, and we have to see how that will be done. Okay, there are 4 different ways of passing a two-dimensional array to a function. Okay, so now passing an array to a function and returning an array from a function are slightly different. Okay, so here is the way of passing a two-dimensional array to a function. Okay, okay, so how do we do that? There are 4 different ways I said. So one is array to array. Okay, we can pass an array. We can in the call to the function we can define array A. Okay, and in the function we can define another array B, and then this would pass an array to an array. We will see in a program how this is done. Okay. Another way to do is to pass an array to a pointer. Okay, so this is a statement of P. Let's say an array A of dimension m by n is passed on to a pointer P. Okay, simply. Okay, another way of doing is now array to a one-dimensional pointer. Okay, so we've seen that you can use a pointer, a simple pointer, to point to an array. Okay, or we can use an array of pointers, right? So we can use all that to pass the function. Okay, pass it to a function. So one is we pass an array to an array, or we pass an array to a pointer. Okay, or we pass an array to a pointer array. Okay, one-dimensional pointer array. Okay, or we could pass an array to a two-dimensional pointer array. Okay, so we have the 4 different ways of doing this. Okay, so I think that's what we should now see in a sample in a program. Okay, so we will see the implementation of this in a sample code. Okay, so we have an array declared here. Okay, which is 5 by 2 array, 5 rows and 2 columns. Okay, and now I have declared 4 different functions, and we'll see an array to an array to a pointer, array to a one-dimensional pointer array, and an array to a two-dimensional pointer array. That's what we should see. We were talking about 4 different ways of passing an array to a function, and these are the 4 functions which will demonstrate that. So that is, for in the case of print.c, so that's this function. So here we will be passing in an array to an array. Okay, and in this case we will be passing an array to a pointer array, and here and finally into an array into a two-dimensional pointer array. So an array to an array, an array to a pointer array, an array to a one-dimensional pointer array, and an array to a two-dimensional pointer array. So that's 4 different ways of passing this passing an array to a function. Okay, so that's what this particular program shows. So we'll see that also in a program. Okay, so that will be shown here. Okay. So this program actually demonstrates those 4 different ways of passing an array to a function. Okay, so this is specifically to demonstrate that method of passing array to function. As I said, there are 4 different ways of doing it. So that is array to array, array to pointer, and array to one-dimensional pointer array, and array to a two-dimensional pointer array. So all these functions are doing exactly the same thing. They just print out the values of this array elements in the respective functions. For example, print here is a function which receives that array ARR here, okay, as B, array named B. Okay, it has got 2 columns. Okay, so what it does is it just simply prints out that array elements in the function, but it receives this ARR array as an array named B. So remember, in this case, any change in the values of the array made inside this function will also reflect in the main program, because all these 4 ways of passing array elements are all actually by reference, not by value. Okay, so any change you make here will also be reflected in the main program. But here we are not making any change right now, just printing out those values. Okay, that's what the print function is doing. It's just receiving the array as an array. Okay, now let's see what the show function is doing. So in the show case, in that array ARR, remember that was the first element of the function call. That is, here is received as a pointer. Okay, so integer star b is the one which receives the array elements. Okay, so now how do we get the access to the array elements? So then it goes this way, so that b, so we go from I going from 0 to L. Now L is the dimension of the number of columns of the array, which we have passed as 2. So now that means 0 and 1. So you will go here and use that star b plus I star 2 plus 0 and b plus I star 2 plus 1. These are the two elements of one row, right? And then we do that for all columns. Okay, so let's see that again, the call function. So we are calling here show, this function called show, the show to which we are passing this two-dimensional array which we defined here. Okay, and we also pass the number of rows and the number of columns. Okay. So that's m and n, and the function show actually receives that as an integer pointer b. Okay, and the number of rows are now defined received as L, and the number of columns as p. Right. So now this is just one pointer b which is going to read out the entire elements of the array, and the array elements are stored serially. That is, you go along the go in a row along the columns and then come back to the next row, etc. So that's what this is doing, right? So it's printing out each of the rows elements, the first element of the row. So first, when I equal to 0, it is printing out the first element of the first row, it has b plus 0 and b plus 1, right? The star here because because these are pointers. We are printing out the value of that point, what it is pointing to. Okay, and then we increment L, that we go to the next row and then print out that, etc. So now let's see what is the next thing, that is called the function called display. And now display takes array, passes array, again here array, to a one dimensional pointer array. So now we are just passing only the number of number of rows into this one dimensional pointer array. Okay, and then this function display receives it as a one dimensional pointer array. Okay, so each of those pointer array of two elements. Okay, that is why star b, this asterisk b, the two elements in each of those arrays. So then we to print out now the values, we have to use a pointer, we have to use another pointer, okay, which is now here p. Okay, now this pointer p, which it has to be pointed to each of the rows, and then we have to move along the columns to read out that elements. Okay, now that's what it's doing here. So p is now pointing to the base address of this array, one dimensional pointer array b, right? P is pointing to that b, and then p and p plus 1 will give the two elements of that row. Okay, and then we go b plus plus, that means we'll go to the next row of this pointer array. Okay, right, and then we again use p to point to that and then read out p and p plus 1. So if you pass an array into a one dimensional pointer array like this, then you need to use another pointer to go through those array elements and read out them. Okay, now the last method is to pass an array to a two-dimensional pointer array. Okay, and that is shown in the last program. Okay, so the last function here, that is called exhibit. Okay, and in this function it receives it as a two-dimensional pointer array of dimension 5 by 2. And then to now print out those elements which are similar to printing out the elements of a two-dimensional array, but only thing we have an asterisk sign here because this is a pointer. Okay, so these are the 4 different ways of passing an array into a sub function. So we will stop today's lecture at this point.